Okay, so today we're going to start working with 3D shapes. Okay, we're going to find the surface area of the 3D shapes and the volume of the 3D shapes. But before we do that, we are going to look at what these 3D shapes are made of. How do we form that 3D shape? Okay, so if I'm looking at a 3D shape, I'm going to have to look at the nets. So what is a net of a 3D shape? So the net of a 3D shape is a 2D pattern that can be folded to form the 3D shape. So think of a pizza box, okay? The pizza box doesn't come as a box. It comes as a cardboard, right? And then what they do is they fold it together, right, to make that shape, okay? Same as with this box, right? So if you look at this one, for example, what shape is this? Rectangular prism, right? Rectangular prism? Yeah. So basically a net is if I break it open, right? I break it open and it's a 2D shape now, right? It's flat. You guys agree that it's flat? Yes. So it's flat. It's made of 1, 2, 3, 4 rectangles and 2 squares in this case. Okay? If I fold it, right, it makes my 3D shape. Okay? This is called a net. All right? So, if I'm going to find the surface area of this prism, basically I need to find the area of each shape, each square, each rectangle, each shape that makes up this 3D prism. Okay? So surface area means finding the area of each side of each face, okay, and then add them together to make the area of the surface area of that 3D figure. Okay? So before we start, so let's look at this shape. This shape is made of what? If you look at it. So remember that this shape has also sides that you don't see, but they are of the other side, right? They're the same. Yeah. So we know that this shape is made of this, which is going to be in the front and the back. What do we call that shape? Do you guys know what this shape is called? How many vertices does it have? 5. It's called a pentagon.
Oh.
Yeah.
Doesn't really look like one, but it is.
It's a pentagon is the 5 vertices. Okay? So I have 2 pentagons, one from this side, one from the other side. And the rest are what? What are these shapes? Rectangles. So these are rectangles, right? Basically, what you have here is this is 10, that means this is 10. If this is 10, that means this is 10, right? And then if this is the bottom is 30, that means this is 30. This is 10, this is 30, this is 10, right? And then basically I have 1.
5.
That's right. So I have 1, 2, 1 on the other side, so that's 3, right? 1 on the other side, so there's 1 on the other side of this, so that's 4, and then 1 on the bottom, so that's 5 rectangles. Okay? So basically this is made up, I don't have a pentagonal shaped prism, but I have a hexagonal shaped prism here. Okay? So you see that the hexagonal shaped prism, right? For each side, you're going to have a rectangle. Okay? So that's why hexagon means 6. So we'll have 1, 2, 3, 4, 5, 6 rectangles to make that Okay, so you see that each side that forms that hexagon is gonna have a rectangle going down. You guys see that? Rectangle, rectangle. So I have a total of 6 rectangles. With a pentagon, there's gonna be a total of 5 rectangles. Okay, so if I'm gonna draw the net of this, it's gonna be like so. So it's gonna be, I'm sorry if it's not like size-wise, it's not correct, but I'll try my best. So you're gonna have 5 rectangles. They're all gonna be equal. And then we're gonna have 2 pentagons coming out of it. So think about this, right? So there's gonna be 2 pentagons coming out of it. Where do you draw the pentagons? Doesn't matter. You wanna draw them on the side, on the edge. You wanna draw them in the middle, doesn't matter. It depends on how you open your shape. Okay, so I'm gonna draw my pentagons right here. These are supposed to be equal sides. So as you can tell, right, the smaller sides is gonna be 10. So basically this is gonna be 10, 10, 10, 10, right? And these are going to be 30, all of them. Right? And then the red lines are going to be 10 as well. So this is going to be 10, this is going to be 10, and so on and so forth. So they're going to be all. Okay? So if I'm going to find the surface area of this shape, I have to find the area of each of the rectangles, and I have to find the area of the 2 pentagonal shapes. Okay? Now the pentagonal shapes, we don't have a formula to find the area for it, but what is the pentagon made of? A rectangle and a triangle, right? Because I'm looking for an area, not a perimeter, right? So it's made of basically a rectangle, in this case it's a square, and a triangle, okay? So to find the area of this, you just find the area of your square, which is going to be, in this case, 100 centimeters squared. And then you have to find the height of your triangle, right? And then find the area of the triangle doing base times height divided by 2. But in this case, it's not asking you to find the surface area, it's just asking you to draw the net, okay? But I'm just giving you a heads up if you have to. So for example, when you're doing your shapes, if you have a pentagonal shape or if you have a hexagonal shape, you're going to have to split the shape into shapes that you know. Okay? And in this case, I can split this into a square and a triangle. Are we okay with this? All right. So this is, what do we call this shape? What's your base? What's the base?
Triangle.
Triangle, so that's a triangular base prism. Okay?
Triangle.
The other one is a pentagonal base prism. This is going to be a triangular base prism. Okay? What is it made of if I want to split it? 3 rectangles and 2 triangles. That's right. So if you look at this, this is exactly what this is, right? Triangular base. Now this is longer than what you see right here, but it's the same idea. You have 2 triangles and you have 3 rectangles. Okay? So let's look at what, if I'm gonna draw them. So I'm gonna have three rectangles. And then I'm gonna draw 2 triangles. Now, what would the long side equal to? 96.5 centimeter. So that's going to be for every single side that goes parallel to it. How about for the smaller sides, these ones? 15.2. So look here, please. Can I have your attention, please? So for the first rectangle, this side makes this side. Right? This side is going to make this side. Okay? Now it happens that in this case, my base is also 15.2, so that's going to be this one. So in this case, I have a triangle, and it's an equilateral triangle. That means all 3 sides are going to be equal to each other. Okay? It doesn't always happen. Sometimes your base is bigger than 15.2 or smaller. Okay? That means this triangle in the middle where you put your triangle is going to be different size. Okay? But in this case it is not, because all my 3 sides are equal in a triangle. So that means when I put the 2 lines, that means all these 2 lines are equal to 15.2. Okay? So this is how we indicate that the lines are equal to each other, by indicating that either like the one line here, that means all of these lines are 96.5 centimeters. Okay? And the 2 lines, that means all of them are equal to 15.2. Are you guys okay with that indication? Are we good with this? Do we understand how to draw the net?
So do we have to put lines during, for example, a test or?
Unless you're gonna write 15.2 for all of them, right? So this is, you don't have to write 15.2 anymore. You just indicate it this way. Can I move on to the next? 1 second, you said? So in the meanwhile, while you're just waiting, start drawing the nets for the next shapes. Make sure you indicate the measurement.